Hey team, it's Mr. Z, and today we're going to look at number 2 and just kind of look at all of the functions from the previous problem. We're going to identify the number of zeros, and then we're going to write about the multiplicity. Let's go ahead and dive on in. So right now the idea is that for the zeros, you have to ask yourself, hey, how do I get an output of 0? That's why they're called zeros. Zeros are the x-intercepts. So when you're looking at it all, the question you ask yourself is, hey, how do I make it equal to 0? So in every single instance, you're asking yourself the same question. Now, you can go ahead and write out all of the cases on a separate piece of paper, but the idea is that with a little understanding, you can alleviate a lot of work. I know that for the function f of x, that 0 is going to be the solution. Why? 0 equals 0. So x is equal to 0, and that's it. There is 1, 0, 1 x-intercept, and then it has a multiplicity of 1. All right, continuing. Same idea. What number minus 1 is going to end in an output of 0? Well, 1. Again, this is going to be 1, 0, 1 x-intercept. They're the same thing. And since it has an answer, it's a multiplicity of 1. Just kind of trust me. Now, here in this next one, it's going to be a combination of both. Notice how many answers are going to be. There are going to be 2 zeros. 1 from here, 1 from here. We know it's going to be x is 0 and x is 1. In each of these is going to be a multiplicity of 1. Now this is where it gets different. Here, there are 2 zeros, 2 cases, degree 2. It's going to be when x is 1 and when x is 1. It has 2 zeros, but x is 1 has a multiplicity of 2. Because this 0 has repeated. All quadratics, degree 2. Okay. This next one, it's going to have 3 zeros because the degree is 3. You can say quickly that they are when x is 0 and when x is 1. Notice this will have a multiplicity 1. It's only the answer once. Here it's going to have a multiplicity of 2. 3 zeros. Okay. Number 3. What do you notice about the degrees of a function counted with multiplicity in the degree of the function? Basically, the degree of each function matches the number of zeros with multiplicity. So the idea here, team, is the degree of each function matches the zeros with multiplying. Here in f of x, it was degree 1. It has 1, 0. Notice how it matches? But the difference is in j of x, It is degree 2. It has 1 0, but with a multiplicity of 2. 1 times 2 is 2. So that's basically how the degree interacts with the zeros. And when a zero is repeated, we use the term multiplicity.